Hello guys, welcome back to my YouTube channel on the Big Structure Hub. This is a place where you learn, build, and innovate. In today's lesson, I want to talk about retaining walls. So what is a retaining wall? A retaining wall is a rigid structure designed to hold or retain soil, rock, or other material in a vertical or near vertical position. So are rigid structures used to hold or retain soil, rocks, or any other materials in vertical or near vertical position. So that is the definition of retaining wall. So under retaining wall, I want to talk about types. Number one, types of retaining walls. And then number two, I want to talk about earth pressure. Earth pressure on retaining walls. And then the last item is Rankine's theory. Rankine's theory of earth pressure. So those are the three items I will be discussing today. Number one is types of retaining walls. Number two is earth pressure on retaining walls. And then the last one is Rankine's theory of earth pressure. Types of retaining walls. So types So number one, we have gravity retaining walls. Gravity retaining What is a gravity retaining wall? These are retaining walls which rely on their mass and weight for stability. So you can say these are So these are retaining walls which rely on their mass and weight to resist lateral pressure from the soil. So they can be made up of concrete, mass concrete, bricks, stones, etc. So their height is about 4 meters. So their height is about 4 meters. So these are gravity retaining walls. As you can see, the material can be either concrete or bricks or stones. So this one is a trapezoidal retaining wall, also a trapezoidal retaining wall. So that is all about gravity retaining walls. I will proceed to type number 2. So I will erase. So at number 2, we have cantilever. Cantilever retaining walls. So what is a cantilever retaining wall? It is a type of reinforced concrete wall, commonly used to retain soil at different levels. So this cantilever retaining wall, it is one of the most commonly used retaining walls because of because it is economical and its strength. So it is one of the most commonly used retaining walls because it is economical and its strength. It is used for a medium height, about 6 to 7 meters. It consists of stem, number one, stem. Stem is just the vertical slab the vertical slab. And then the base, number 2 is the base. The base is made up of Roman 1, heel, and then number 2, toe. You will see it in the diagram. And then the third one is the shear key, which is optional. So the function of the shear key is to prevent sliding. Again, you will see it in the diagram. So I will erase here and draw a cantilever retaining wall. So this is a cantilever retaining wall. As you can see, it has reinforcement. As you can see, these are reinforcement. And then the heel is on the side of the retained soil or earth. So this is the retained earth or a soil. Then this is the shear key, which is optional. And this is the stem and the toe. So that is all about a cantilever retaining wall. I proceed to number 3, which is counterfort retaining walls. Counterfort retaining walls. So number 3 is counterfort retaining walls. So this is a modified version of a cantilever retaining walls, and it is strengthened by a triangular beams, which is counterforts, that tie the wall and the base together. And then it can hold soil above a height of 6 meters. So that is all about counterfort retaining walls, and I will draw it so that you can differentiate it from other retaining walls. So this is a counterfort retaining wall. As you can see, these are the rectangular beams which is holding, which ties the stem and the base, which is the heel slab, together. So this is the heel slab. As you can see, this is the counterfort, the triangular beam, and this is the toe slab. So that is the counterfort retaining wall. So we have other retaining walls, of which I will not describe them. I will just highlight or state and leave it for you to do more research. So other retaining walls, number 1, we have buttress. Buttress walls. Number 2, semi-gravity retaining walls. Number 3, you have gabion retaining walls. Number 4, we have sheet pile retaining walls. Number 5, we have the anchored and the last one is crib retaining walls. So in your free time, you can do more research about this, and you can also sketch their diagrams so that you may be able to differentiate them from others. So let's now talk about earth pressure on retaining walls. Earth pressure So number 1, we have active pressure. Active pressure. It is symbolized by Ka. So what is an active pressure? So this is the minimum pressure exerted on a retaining wall by the soil and the wall is free to move. So we call it tension. So if I can draw here a retaining wall, so this is a retaining wall, and this is the retained soil. So this soil, it exerts pressure on this retaining wall. So it exerts pressure on this retaining wall. So this is the active pressure. So this active pressure from the soil will cause this wall to move away from the soil. So it will move away from the soil. So we call it tension. So this is what we call active pressure. Pressure exerted on the wall by the soil, causing the wall to move away from the soil, which is tension. We proceed to number 2, which is passive pressure. So the passive pressure is symbolized by Kp. And what is our passive pressure? Is the maximum lateral pressure exerted by the soil on a retaining wall causing the wall to move into the soil, causing the wall to move into the soil. So I will draw it. So this is the retaining wall. And this is the retained soil. So this retained soil, it exerts pressure on this wall. So this is Kp. This is the passive pressure at a height of h. So when this retained soil, it exerts pressure on the wall, it causes this wall to move into the soil. So the wall will move. So this is wall movement. So that is compression. We proceed to earth pressure number 3. So earth pressure number 3 is earth pressure at rest. Ko. So what is earth pressure at rest? So this is the lateral pressure. When the wall does not move. So the wall will remain in a stable condition and it will not move. So this is the wall. And this is the retained soil. And this is the pressure, earth pressure at rest. Acting at a height h. So no movement of the wall. So those are the 3 types of earth pressure on retaining walls. We now move to the last item, which is Rankine's theory. So the last item is Rankine's theory of earth pressure. Rankine's theory of earth pressure. So what is Rankine's theory? So this is a theory which is used to determine the pressure exerted by the earth or soil on a retaining wall. It is used to determine the pressure exerted by the earth or soil on a retaining walls. So we have assumption made by Rankines in the process of determining this pressure exerted by the earth on a retaining wall. So assumption number one, soil at plastic equilibrium. So the soil is at plastic equilibrium. Number two, no friction between the wall and the soil. And then number three, soil level is horizontal and coincide with the top of the soil. Soil level is horizontal and coincides with the top of the soil. Number four, the wall is vertical. Number five, soil is dry. Soil is dry. Soil is dry. Cohesionless. Cohesionless or has constant cohesion. Whereby C is equal to 0. So that is the assumption made by Rankines in the process of determining the pressure exerted by the earth or soil on a retaining walls. So I will proceed direct to the formula. The formula, as a result of this Rankine's theory, so I will give you the formula. So the horizontal force exerted by on the wedge which is P is given by W H square over 2 into bracket 1 minus sine theta over 1 plus sine theta. So this is the formula for the horizontal force, which is P on the retaining wall. So acting at a height of h over 3 from the base, like that. And then we have the pressure intensity at the bottom. So pressure intensity at the bottom is given by pressure at the bottom is given by WH 1 minus sine theta over 1 plus sine theta. So there is a lot of derivation about Rankine's theory so that you can arrive on these formulas that will enable you to arrive on these formulas, but I have just skipped them because there's no need to do a lot of derivation when we only need the formula to tackle the questions. So these are the formula you should know. So I think from here you can tackle more questions concerning the stability of retaining walls, the stresses at the base of the retaining walls, and the calculation of the minimum bottom width of the retaining walls. So in my next session, I will be tackling more examples, and to be specifically, the examples will be coming from past papers, that is Kenya National Examination Council or SIDAC. So stay tuned for more from Odavig Structural Hub. So I will end there for today. And for those who have not subscribed to this channel, please don't forget to subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. Thank you for your time, and we meet again in my next session.